Hi there, this is Zifan, and I'm doing a quick demonstration on the DCIR job using SIwave. So first, we have the SIwave open here, and then we have a 4-layer PCB imported. So the first step we are going to do DCIR job analysis is we need to first verify the layer stackups. So here we have the layers, so we want to make sure we have the material properties and the thickness and um, the material properties correct. So here we have 4 metal layers and with the electric layer in between the metal layers. So we are using copper in this case and FR4 for the dielectric. So after we verifying the layer stack up, next is we want to go to the circuit elements. We want to make sure all the circuit elements are imported. In this case, we have capacitors, inductors, and resistors. So make sure all the components are imported. And next is we can go to the left hand side here. Here we have the components. So we can check the discrete device. Here we have two discrete device. So once we make sure the setup is correct and all the components are imported, then we can start our simulation. So now we want to go to the SIwave workflow wizard. So if you open a plain SIwave, if you open a plain SIwave window, then this wizard will automatically pop up. But if you open a project, then you can open this window at the left upper corner. So here it will give you kind of a guidance, help you check that everything is correct. So like we first set the layer stack up, and we can verify the pad stack, which is the vias. And next we can verify the circuit elements and the power and ground net. We usually use auto identified, but in case you are missing some power ground nets, you can automatically bring it up and down here. Okay, so next is sanitize the layout. So sanitizing the layout is uh, just do a power and ground plane sanitization. It helps us to clean up the plane and faster the make the simulation of the power and ground plane faster. So you just simply cat sanitize and it will automatically do all the jobs for you. And we click OK. So next is we go to configure DCIR job analysis. So here we want to enter the voltage source or current source or any input source that you have to the corresponding nets. Then so in this case, if we look at the spreadsheet here, we have 3 sources here. So we have the input power for the gate driver. We have the input power for the secondary driver A. And here we have the input power for the secondary driver B. So for the gate driver, we have 3.3 volt, and here the driver A we have 15 volt, driver B we have 15 volt. So these are the voltage source. So if let's go back to the so let's check out what nets are them. So the first one is the the 385 nets, 178 and 913. So now we are back in the SIwave. So let's see. We have the 385, we have the 178, and we have the 913. Okay, and so for the 385, we have the ground net is 0. Then the source, which will be the voltage source, is 3.3 volts. And here we have the 178 with power ground, 178 with power ground. This will be our next voltage source and it's 15 volts. And we also have the 913 with power ground and it's also voltage source 15 volt. Okay, so after we set out our voltage source, we can next just configure simulation. After the configuration, we can do the validation. Here we just okay. We can usually just leave it as default, and we hit OK. And looks like there's no errors or no warnings, so we just click OK, and we can do the simulation. Here is check for the ice pad option. So if you are going to do the thermal analysis afterward, you can do you can export the power dissipation for the use in ANSYS iPad and mechanicals. And here is the operating temperature. And here is the select ideal grounds 0 volt nodes. Here, so we usually just whichever is the 0 volt net. We set which is the ground. We give it a negative. So the negative net is a ground which is 0, and here's 0, and here's 0 volt. So we have the ground set up. And if we go to the other solver options, here is you can choose to compute the inductance or not. And if you go to the DC advance, usually we just restore default for this, and we go to a multiprocessing. Here is allows how many cores you want to use for your simulation. And if we hit OK and then we hit launch, so I do not want to over my results, so I'm going to change the name, just launch. Okay, so this is very small design, so the results coming out quickly. And then we can just plot our current and voltages. So here you can see we have the VR current, we have the current density, we have the voltage, we have the power density. So let's make it let's move it a little bit, like move it here. So on the left hand side is the nets that we want to show. So just update the nets a little bit. Let's see, so here's the power ground plane, so which is 0. So you can see there's it's a 0 volts. It's blue. I'm wondering why the color chart is not showing. But okay. Okay. So let's hide all of this. We can look at one at a time. So let's show voltage. If we click voltage, and we can zoom it in a little bit. Let me go ahead and hide the ground nets. Update plot. Okay. So now we can see we have the voltage plot on the 4 different layers, right? So we can, if you hold down your center wheel of your mouse, you can rotate the design and look like this. The blue is the 3.3 volt, and then the red is 15 volts, right? Or you can just plot it at a certain plane. Then if you want to plot the current density, you can do so. You will have the arrow showing how the current flows, in the design. We can update it, right? So now we have the current flowing map of our PCB, and we can plot the power density. And if you want to just look at the VR, you can plot the VRs. And here we can see there's a circle and a cross. So the the circle and the cross is the current magnitudes between the layers. So the circle means the current is going towards the top of the stack, and then the cross means the current is going away from the top of the stack. Right, so in this case, like this one, the current is going up and down because it's sent cross at the center and then it's circle at the top and the bottom. So here is the voltage and current plots, and next we can look at even more data. So for example, the RL table, it will give you the resistance and the inductance, and we can also export the reports. So if we click export reports and then report fail, okay, I will check this, and then we want to just report the region that's below or above a certain voltage. In this case, if I put 3 volts, I hit OK. It's generating the report, and you can choose to open the report in the web browser. So here we have the simulation report with the layer stack of information. We have the voltage source, and here we have the results. Right, so we have all different results with the VS current, with the current plot of here's the top layer, current plot of the top layer. We have the current plot on the ground plane, so we can see how the current flows. V power plane, we have the bottom layer, and here is the VS, and here's the voltage plot. So you can generate this type of report, and you can give you a very straightforward view. Okay, so this will be all for this DCIR job simulation. So if you have any question, feel free to reach out to me. This is Zifan, so I will put my email on the on YouTube as well. So whoever is watching the YouTube, feel free to reach out if you have any questions. Thank you.